This is Euclid Book 10, proposition number 100. Okay. The square on a minor straight line applied to a rational straight line produces as breadth a fourth apotome. Let AB be a minor, okay, this is a minor right across here, and CD a rational straight line, that's across here. And to the rational straight line CD, we're going to apply the area CE, which is this right across here. And this area is going to be equal to this area right here. Now, how did we get this area right across here? Alright. We took line AB and we turned it into a square, and all four sides of that square are going to be the length of AB. That's how we got that square. Now we're going to produce CF as the breadth. That's this right across here. I say that CF is a fourth apotome. For let BG be the annex to AB. We're going to annex this line to this. Okay? Therefore, AG and GB, okay, this line right across here and this line right across here, they're straight lines. They're incommensurable in square. Okay? So in other words, these two squares right here, now how did we get these? We took the line AG, we turned it into a square, and all four sides of this square are going to be the length of AG. We did the exact same thing with BG. We took this line, we turned it into a square, and all four sides of that square are going to be the length of BG. That's how we got those. Okay? Now, the sum of the squares on AGGB, we took these two areas, we added them together, and those areas are rational, but twice the rectangle AGGB is medial. Now, how did we get this rectangle right here? Alright, what we did was we made a rectangle. Two sides of this rectangle are going to be the length of AG. Let me say that again. Two sides of this rectangle are going to be the length of AG. The other two sides of this rectangle are going to be the length of BG. That's how we got that rectangle. So if we take this area and we multiply it by 2, we get a medial area. That's by Euclid Book 10, proposition number 76. To CD, let there be applied CH. To CD, we're going to apply CH, which is this, this, and this. If you add this area and this area and this area together, you get CH. This, and this is equal to the area on AG, and it's going to produce CK as the breadth. Now, we're also going to apply this area KL right across here, and it's going to be equal to the area of BG. This area is going to be equal to this, and it's going to produce KM as the breadth. Okay? Therefore, the whole CL, that's this, and this, all four of these areas combined, is equal to this area plus this area, these two areas together. And we already know that the sum of these two squares is rational. Okay? Therefore, this, and this combined is also rational area. And it's been applied to the rational straight line CD, which is this. And it's going to produce CM as the breadth, which is this. Therefore, CM is also rational, this is rational, and it is commensurable with CD. That's by Euclid Book 10, proposition number 20. And since the whole CL, this whole area right across here, all this, is equal to the squares on AG and GB, so this plus this equals this, and this, and in these, CE is equal to AB. Therefore, the remainder FL, which is this, and this, is equal to twice the rectangle AGGB. Okay, so we take this area, we multiply it by 2, we get this, and this. And that's by Euclid Book 2, proposition number 7. Let then FM be bisected at N. This line is going to be bisected right here. And let NO be drawn, which we have done. This line is going to be parallel to either this or this, either one. Therefore, each of the rectangles FO and NL. What is FO? That is this area right across in here. It's FEON. That's this area. And NL. The rectangle NL is this and this together. This is rectangle NL. Okay. Now, this is equal to this in area. Okay, this area is equal to this one, and this area is equal to this one. And since twice the rectangle AGGB, we multiply this area by 2, it's going to be medial, and this area is equal to this, this, and this. Therefore, this, and this together is medial. And it has been applied to the rational straight line FE. Okay? This, and this has been applied to this. And it's going to produce FM as the breadth. Okay? This is the breadth right across here. Therefore, FM is rational. This line is rational. And it's incommensurable with CD. Okay? That's by Euclid Book 10, proposition number 22. And since the sum of the squares on AG and BG, okay, since this and this together is rational, while twice the rectangle AGGB is medial, we know this. If we take this area, we multiply it by 2, we know that's medial, and we know this and this together is rational. The squares on AG and GB, this sum right here, is incommensurable with twice of this. But CL is equal to the squares on AG and GB. This, and this is equal to this plus this. And FL is equal to twice the rectangle AGGB. This multiplied by 2 equals this, and this. Therefore, CL is incommensurable with FL. This, and this is incommensurable with this, and this. But as CL is to FL, as this, and this is to this, and this, so is CM to MF. So is this is to this. That's by Euclid Book 6, proposition number 1. Therefore, CM, that's this, is incommensurable in length with MF. And that's this. And that's by Euclid Book 10, proposition number 2. And both are rational. Therefore, CM and MF, this line here and this line here, are rational straight lines. They're commensurable in square only. Therefore, CF is an apotome. This is an apotome. That's by Euclid Book 10, proposition number 73. I say that it is also a fourth apotome. Okay, we're going to say that CF here is a fourth apotome. For since AG and GB are incommensurable in square, since this line and this line are incommensurable in square, therefore the square on AG, that's this, is also incommensurable to the square on BG, which is this. These two are incommensurable. And CH is equal to, okay, and CH, which is this, and this, is it, okay, this, and this is equal to this area right here. And we know that this area is equal to this area right here. Therefore, this, and this is incommensurable with this. But as CH is to KL, as this, and this is to this, so is CK to KM. This is by Euclid Book 6, proposition number 1. Therefore, CK, this right here, is incommensurable with KM, which is this right here. This is by Euclid Book 10, proposition number 2. And since the rectangle AGGB, which is this, is the mean proportional between the squares on AG and GB, this is a mean proportional between this and this, and the square on AG is equal to CH. Okay? This is equal to this, and this, and this is equal to that. And the rectangle AGGB, which is this one right here, is equal to NL, which is this and this. Therefore, this and this is a mean proportional between this, and this, and that. Therefore, as CH is to NL, as this, and this is to this and this, so is NL to KL. so as this is to that. But as CH is to NL, as this, and this is to this and this, so is CK, this here, this line right across here, is to this line right across here. And as NL is to KL, as this and this is to that, so is NM, which is this, is to KM, which is this. Therefore, as CK is to NM, as this is to that, so is MN, which is this, is to that. That's by Euclid Book 5, proposition number 2. Therefore, the rectangle CKKM, the rectangle CK, that's it right here, this one right here, is equal to the square on MN, which is this, which is by Euclid Book 6, proposition number 17. That is to the fourth part of the square on FM. Okay? So, this is equal to the fourth part of the square on FM. Since then, CM and MF, since CM and MF are two unequal straight lines, and the rectangle CKKM, which is this, is equal to the fourth part of the square on MF, which is this, and division by a square figure has been applied to CM and divided in incommensurable parts. Therefore, the square on CM, which is this, is greater than the square on MF, which is this, by the square on a straight line incommensurable with CM, which is by Euclid Book 10, proposition number 18. And the whole CM, which is this line right across here, is commensurable in length with the rational straight line CD set out. Therefore, CF is a fourth apotome. This is by Euclid Book 10, third set of definitions, number 4, and that's the end of the proof. Alright, I will tell you more in a future video. I want you to stay tuned.